we are going to go over the derivative of trig functions. And what we can see here gives us the derivative. So if you take the x-axis to represent where sign is supposed to be, so this is the x-axis, the positive x representing positive sign and the negative x representing negative sign, and the y-axis where the positive y-axis is representing cosine, the negative y-axis is representing negative cosine. And so when you are going in the anti-clockwise direction, if you get to differentiate sin, you are going to get cos. If you differentiate cos, you get negative sin. Differentiating negative sin, that gives you negative cos. And if you go in the opposite direction, then you are integrating. So this is what we need to get to understand when you are differentiating trig functions. Now let's look at some practice. Say we've been given to find dy over dx, or to find the derivative of the first one, y is equal to x squared plus sin x. Well, we know the derivative, that is dy over dx of this function, is going to be, first we are going to find the derivative of x squared, and that is 2x, and then next we go to the sin. Now when we are differentiating a trig function, the first thing that we need to get to differentiate before we do anything is to differentiate just this, just the trig ratio itself, and then we are going to go on and differentiate the angle. So those are the things we are going to be doing in all of the trig derivatives. First differentiate the trig without consideration of the angle, and then differentiate the angle. So the derivative of sine, we know that that is cosine. Now the derivative, so that will be cosine, but the angle first we maintain it. Now again we differentiate the angle x, that will just be a 1, and so that will just be cos x. So that is going to be it for this one. Now say we want to differentiate, what if we want to differentiate y is equal to x squared, let me use another number, x to the power 3 plus cosine of 2x. What is it going to give us? So dy over dx is going to be equal to, first differentiate this, and that is going to give us 3x squared, and then plus, let's differentiate just cos, the angle maintained. So the derivative of cos, that gives us negative sign. The angle, we maintain it, we don't change anything, and then we differentiate the angle now, 2x. If we differentiate 2x, what do we get? We'll just get a 2. And so this is going to give us 3x squared. I'll multiply these two with the negative sign. So this 2 doesn't multiply the angle, it multiplies the ratio itself. So that will be negative 2 sine 2x. So that becomes the answer here. What if we want to find the derivative of y is equal to sine cubed x? How are we able to do that? Now we need to get to realize that sine cubed x is the same as saying y is equal to sine x to the power 3. And we can use the power rule on this one. So dy over dx, firstly we are going to just get the power 3 multiply with the function, just like when we have 2 minus x to the power 3. We first get, so to find dy over dx for this one, we'll simply get 3 first and multiply with the function, and then reduce the power by 1, it becomes 2, and then differentiate now what is inside, and that will be a negative 1. And so this gives us negative 3 2 minus x squared. So in the same manner as we've done this one, this is how we get to work out also trig functions which are raised to powers. And so this is going to be, first we differentiate, we get to multiply the 3 with the whole function, so that will be 3 sin x, we reduce the power by 1, that becomes power 2, and then we multiply. Now we differentiate what is inside. Now when we're differentiating what is inside, the first thing that we get to differentiate is a sine, and that is going to give us cosine. We maintain the angle x, and then we differentiate the angle x, which will just be 1. And so we can simplify this into saying this will be 3, I'll start with the cos x, and then now write this well, that will be sin squared x. So this is going to be the derivative for this one. So what is the difference when we have y is equal to sine x cubed? Well, we need to get to realize sine x cubed is not the same as sine cubed x. These two are not the same. Here it is x which has been cubed, but here it is the ratio which has been cubed. In other words, it is the whole function cubed. It is sine x and then raised to the power 3. As we also wrote, this is the same as sine of x raised to the power 3, but here it is just the x which is raised to the power 3. So we need to get to differentiate that also. And so finding the derivative for this one, that would be dy over dx being equal to, we'll first differentiate the sine. If we differentiate sine, that will give us cosine. We maintain the angle the same way it is, and then now differentiate the angle. That will be 3x squared, and that is going to give us 3x squared cos x cubed. So this always multiplies in front of our function. Let's look at more. What if we have y is equal to negative cos cubed, let's say 4x? How do we get to differentiate this one? Well, we know this can also be written as negative cos 4x, and then the power 3, we can also write it outside like that. So work it in using the power rule. So that will be dy over dx giving us, first we get the 3 and multiply with the whole function. So that will be 3 open brackets negative cos 4x, and then we reduce it by 1, that will be power 2, and then now we multiply, we differentiate what is inside. Now the derivative of negative cos, that is positive sin. Okay, perhaps we've just forgotten that negative cos gives us positive sin, and so that will be sin, but we maintain the angle. We are differentiating what is inside. We just differentiate the negative cos, that will give us sin. We maintain the angle 4x, and then after that now we differentiate the angle 4x, and that will be just a 4. And therefore this is going to give us, here we can multiply the 3 and the 4, that is going to give us a 12. We also have a negative here, so that will be negative 12, and then we have got cos squared 4x, and then we have got sin 4x. So I've just written this with a squared here, it's the same thing really. So that is going to be the derivative for that one. What of the derivative for tan x? Well, we know that tan x is the same as sin x over cos x. And from here what we can see is that we've got a quotient. So using the quotient to dy over dx is equal to v du over dx minus u dv over dx divided by v squared. And the v is what is in the bottom. So first get what is in the bottom, that is the cos x, and then differentiate what is on top. If we differentiate sin, we get a cos, minus, we get now the u, the one on top, we differentiate what is on the bottom, cos x. The derivative of cos x is negative sin x, and then now get what is on the bottom, that is the v, we square it, so that will be cos squared x. So this will give us cos x times cos x, that is a cos squared x, negative sin x times negative sin x, that will be positive sin squared x, then divided by cos squared x. And so we know that cos squared plus sin squared is a 1, so this is 1 over cos squared x, and this is going to give us tan, okay, sorry, not tan, cos, 1 over cos, we know the reciprocal of cos is sec, so that is going to be sec squared x. So this is the derivative for tan. So d over dx of tan x is sec squared x. Let's look at this one. What's the derivative for sec x? So before we even get to find the derivative, we know that sec x is the same as 1 over cos x. So we also have a quotient, and so this will be v du over dx minus u dv over dx, and then divided by v squared. So the v, what is in the bottom, that is cos x. The u is what is on top. So if we get to differentiate 1, we are going to get a 0. And then minus the same 1 which is on top. We differentiate what is down, that is a cos x. That is going to give us negative sin x. Now divide by what is in the bottom squared. So of course this is a 0, and negative 1 times negative sin, that will be positive sin x. In the denominator I can also write this as cos x, and so I can also split it in this manner, sin x over cos x, and then 1 over cos x. So sin x over cos x, that is a tan x, and 1 over cos x, that is sec x. So this is the derivative for sec x, is tan x sec x. Now what if we want to find the derivative of negative sin x plus xy plus, let's say, 2x to the power 3 is equal to 1? How do we get to find the derivative for that one? Well, I'm going to put d over dx, meaning we want to find the derivative of this function. Now we can see this is not a quadratic function, it's not a linear function, it is a implicit function. That is because it is a function of x and y. So what we are going to do here is we first get to differentiate this term. If we get to differentiate negative sin, we are going to get a negative cos x. And then we come here, differentiate xy. Now we can see we have got a product of two functions. So the first thing, we're going to maintain one, differentiate the other, and then maintain the other, differentiate the other. So let me maintain x. That will be x, and then differentiate y. If I differentiate y, I'm going to get a 1, but every time I differentiate y, I'm supposed to add dy over dx, and then plus. Now I'm going to maintain y, and then differentiate x. Every time I differentiate x, I'm supposed to add dx over dx. When I differentiate x, I'm supposed to add an x on top. Now dx over dx is a 1. Every time I differentiate y, I'm supposed to add the y here. So that is why it gives us dy over dx there. And then now we have got plus. We differentiate 2x to the power 3. That is going to give us 6x squared. That will be equal to differentiate 1. That will be a 0. So this is the same as negative cos x plus x dy over dx plus y plus 6x squared is equal to 0. So that will be x dy over dx is equal to, I'm taking everything that doesn't have dy over dx to the other side. We have got negative 6x squared. This one, if it goes the other side, we have got negative y, and then the cos, if it goes the other side, becomes positive. So positive cos x. So to remain with dy over dx, I'm going to divide by x both sides. So dy over dx, that is going to give us negative 6x squared minus y plus cos x divided by x. So that is going to be the derivative for this practice question. Let's get to understand some other trig derivatives and combining them with some implicit functions. Now, what if we are talking about tan xy is equal to 1? How do we get to differentiate this one? Well, d over dx of this also function is going to be equal to, the first thing is we get to differentiate tan, and we already saw that when we differentiate tan we get sec squared, so that will be sec squared. We maintain the angle the way it is, that is xy. After doing that, now we're supposed to differentiate the angle. Firstly, I'm going to because for the angle I've got an implicit. I'm going to first get x the way it is, and then differentiate y. That will give me 1. And every time I differentiate y, I need to add dy over dx. And then plus, I'm going to maintain y the same way it is, and then differentiate x, and that will be a 1. And that is going to be equal to, if we differentiate a 1, we're going to get a 0. So this is sec squared xy, and then we have got x dy over dx plus y is equal to 0. So I'm going to distribute now sec squared to these. That is going to give us, now this will multiply in front and not the angle, because if we do that, that would be a mistake. So that would be x dy over dx sec squared xy plus, and then we get to multiply this with the sec, that would be y sec squared xy is equal to 0. So I'm going to take this the other side because it doesn't have any dy over dx. So that will give me x dy over dx sec squared xy is equal to negative y sec squared xy. Now for me to remain with only dy over dx, I'm going to divide by x sec squared xy. So that will be dy over dx is equal to negative y sec squared xy divided by x sec squared xy. Now we can see that this and this can cancel, so that will just give us negative y over x. So that is going to be the derivative. Let's look at another one. What if we have sin xy plus x squared is equal to 5? How do we get to differentiate this one? Well, we are saying we also want to perform the derivative d over dx of our function here. And that is going to be equal to, first we differentiate sin, that is going to give us cos. We maintain the angle xy. And then now we go on and differentiate the angle. That is going to be, first we maintain x, we differentiate y, that will be 1. And every time we differentiate y, we add dy over dx. And then plus, we maintain y, we differentiate x. That will just be a 1. And then plus, we find the derivative of x squared. That will just be a 2x. The derivative of 5, that is a 0. So this is cos xy x dy over dx plus y, and then plus 2x is equal to 0. Now we get to distribute the cos xy. So that will be x dy over dx cos xy, and then plus y cos xy plus 2x is equal to 0. So this will give us x dy over dx cos xy is equal to, I'm taking these terms we don't have a dy over dx the other side. That will be negative y cos xy and then negative 2x. Now divide by this to remain with dy over dx. Dy over dx is going to be negative y cos xy minus 2x divided by x cos xy. So that is going to be the answer for that one. Now what if we're talking about, let's say 5 is equal to x squared sin y. Want to find the derivative for this one. Well, same d over dx for this function. We can see it is also implicit. That is going to be equal to, first we differentiate 5. That is going to give us a 0. And that will be equal to, now here we have got a product of two functions. So let's first differentiate this, we maintain the 1. So let me first maintain x squared, and then I'm going to differentiate sin y. And if I differentiate sin y, that gives me cos y. After differentiating the sin, I'm supposed to differentiate the angle. And if I differentiate y, I'm going to get 1. and every time I differentiate y, I'm supposed to add dy over dx. And then I'm going to now maintain the sin y and then differentiate the x squared, and that will be just 2x. So this is going to give us 0 is equal to x squared cos y dy over dx plus this would be 2x sin y. I'm going to take this term the other side. So we're going to have x squared cos y dy over dx is equal to, so I've written first this one and then I take this one now the other side, so it becomes negative 2x sin y. So to remain with dy over dx, that is going to be negative 2x sin y and then divide by x squared cos y. So this is going to be the derivative. Of course, we can cancel out an x there and also an x here, so that will give us negative 2. And also we can see sin and cos. So let me just simplify that one further. So we are saying an x can cancel out, so that will remain negative. We are going to have a 2, and then down we are going to have 1x. Now sin y over cos y, that is tan y. So that is going to be it. Well, let's look at the last question. We can see how to work it out. If we have got sin tan x plus, let's say, y squared plus 3x is equal to 1. How do we find the derivative of this one? Now we can see that for sine, the angle here is tan. So this is different when we wrote sine x and then tan x. This is different. This would have been a product. But this is sin tan x. That means the angle is not there. The angle for sin is the same tan x which you put there. And so, how do we get to differentiate that one? So d over dx, the first thing is we're going to get the sin differentiated. That is going to give us cos. We maintain the angle, that is tan x. After doing that, we are multiplying this with the derivative of the angle. The angle is tan x. What is the derivative of tan x? That is sec squared x. And then plus, we're going to find the derivative of y squared, that is 2y. Every time we differentiate y, we put dy over dx. And then we find the derivative of 3x, that will just be a 3. Derivative of 1, that is a 0. And so I'll just remain with the portion that has got dy over dx. The other portion, I'll take the other side. So that is, I can also start with a sec. So that is sec squared x and then cos tan x. Okay, this is the thing here. And then we also have a minus 3. And then to remain with dy over dx, I'll simply divide by 2y. So that is going to be sec squared x cos tan x minus 3, and then divided by 2y. So that is going to be it for this video. Well, thank you so much for having watched. Hope you enjoyed.